Hello everyone, let us have another session. Let us try to solve another civil engineering licensure examination Psad board exam problem. And this is actually our problem number 2, and it's all about moving loads. First and foremost, let us talk about the moving loads first. And what's all about the moving loads? Let me start. The bending moment under a particular load is a maximum when the center of the beam is midway between the load and under the resultant of all loads on the span. And also, the maximum shearing force is equal to the reaction to the resultant load. Let us now start solving a problem. A truck with axle loads of 40 kN and 60 kN on a wheelbase of 5-meter rolls across a 10-meter span. In this given situation, we need to compute for the maximum bending moment and the maximum shearing force. Let's see the figure below. Let us now start solving the problem. Considering the given figure, as we can see, we have two axle loads of 40 kilonewton and 60 kilonewton, wherein they are 5 meters apart. And in this situation, we need to consider the maximum moment under P. So what do you think we're going to do in this problem? As we can see, we have two reactions, the R1 and the R2, and the resultant force is equal to 100 kilonewton. Now, in order to calculate for R sub 2, I think the best way is to take moment at point A, or summation moment at A is equal to 0, clockwise moment positive as consideration. Let us have now our summation moment at A is equal to 0, considering clockwise moment positive. Before doing any calculations, let us have first an observation of our given figure. Since we need to take moment at point A with a clockwise moment positive, let us try to observe the resultant force 100 kilonewton. 100 kilonewton is 6.5 meters away from point A, and it is actually a clockwise moment. That is why the sign convention that we're going to use is positive, while the reaction 2 at point B is 10 meters away from point A, and its rotation is counterclockwise. That is why the sign convention that we're going to use is minus. That is why we have now our given equation as 100 kilonewton times 6.5 meters minus r sub 2 times 10 meter equals 0. Calculating it, we're going to have an answer of, and our final answer is r sub 2 equals 65 kilonewton. And now let us have the summation of all vertical forces be equal to 0. Let's calculate. Considering R sub 1 and R sub 2 as reaction forces, as we can see that both of them are upward in direction. That only shows that the sign convention that we're going to use in this reaction is positive. While the resultant force 100 kilonewton, its movement is downward. That is why we will use a negative sign convention. That's why our given equation will become, it will become R sub 1 plus R sub 2 minus 100 kilonewton equals 0. And since we already have a value for R sub 2 which is equal to 65 kilonewton, we can now calculate for R sub 1. And R sub 1 value will become, I think this is 35 kilonewton. Let us see it. Then finally, the value of R sub 1 is 35 kilonewton. Coming up next, let's solve for moment at point P. which is actually equal to summation moment at P or MP is actually equal to R sub 1 times X. In this particular situation, the value of our X is actually 3.5 meters. Now by direct substitution, M sub P is equals to 35 kilonewton times 3.5 meters, and that is equal to 122.5 kilonewton meter. And that's our moment at point P. Considering moment under point Q, let us see if it is the maximum or the previous one. Considering this given figure as shown in our slide. So let us try solving the problem. Let us have a moment at point A, or take the moment at point A, or summation moment at A is equal to 0, clockwise moment positive. As we can see in the figure that the 100 kilonewton resultant force is 4 meters away from point A, while the reaction at point 2 is 10 meters away from point A with the direction of counterclockwise. That is why our equation becomes 100 kilonewton times 4 meters minus R sub 2 times 10 meters equals 0. Then finally, our answer to reaction at point B or R sub 2 equals 40 kilonewton. Let us have now our summation forces vertical calculation or summation at y equals 0. In our given figure, it can be observed, or actually it is very obvious, that R sub 1 and R sub 2 as reactions are both upward in direction. That's why we're going to use a positive sign convention. While 100 kilonewton as resultant force, we're going to use a negative sign convention. Again, what we have now is R sub 1 plus R sub 2 minus 100 kilonewton. Let's try now to solve the problem. By the way, the value for R sub 2 is already computed, and that is 40 kilonewton. And substituting that to this given equation, our equation will become R sub 1 plus 40 kilonewton minus 100 kilonewton equals 0. Then the value for R sub 1 is now 60 kilonewton. Let us solve now for the moment at Q. Moment at Q or MQ is equals to R sub 1 times X minus 100 kilonewton times 2 meters. Since 100 kilonewton is 2 meters away from point Q, and supposed to be what will be the value for X. X in this particular situation is 6 meters actually. MQ now is 60 kilonewton times 6 minus 100 kilonewton times 2 meter. Then finally, the value for MQ is 160 kilonewtons. If we will try to recall, our moment at point P is 122.5 kilonewton meter, while our moment at point Q, as we can see now, is 160 kilonewton meter. That is why we can then conclude that the maximum moment that we have in this equation is 160 kilonewton meter, because 160 is greater than 122.5. Thus, the maximum moment is 160 kilonewton that meter. Finally, our maximum moment is 160 kilonewton meter. Calculating for the maximum shear load, let us position first the second wheel to the right end of the span, and that is actually the 60 kilonewton wheel, positioning it at the point at the right end of the span. Now, looking at point B, we can then compute now for the maximum reaction at point B. So let's try to have summation moment at A again equals to 0, considering clockwise moment positive. Since the resultant force 100 kilonewton, is 8 meters away from point A, while the reaction at point B, R sub 2, is 10 meters away. In a rotation of counterclockwise, the sign convention of R2 will be negative, while the resultant force is positive since it is clockwise moment in direction. So let's calculate now. Our given equation is 100 kilonewton times 8 meters minus R sub 2 times 10 meters. So what is then the value of R sub 2? Finally, R sub 2 value is 80 kilonewton. Let us have now the summation of all forces vertical be equal to 0. Then let's try to calculate for the value of R sub 1. R sub 1 plus R sub 2 minus 100 kilonewton. As we can see, the sign convention of both reactions are both positive because their directions are both upward, while 100 kilonewton sign convention is negative or minus since its direction is downward. Coming up next, R sub 1 plus 80 kilonewton minus 100 kilonewton equals 0. 80 kilonewton appear in our equation because the value of R sub 2 is 80 kilonewton. Now, what is then the value of R sub 1? R sub 1 is 20 kilonewton. Let us try to solve now for R sub 1 and R sub 2 considering maximum reaction at point A. Let us have summation moment at point A equals 0. Clockwise moment positive as consideration. In our given figure, the 100 kilonewton as resultant force is 3 meters away from point A, and its direction is clockwise. That's why we will use positive sign convention. While R sub 2 is 10 meters away from point A, and its rotation is counterclockwise. That's why we're going to use negative sign convention. That is why we've arrived with the equation of 100 times 3 minus R sub 2 times 10 equals 0. Coming up next, after transposing R sub 2 times 10 meters to the right hand side of our equation will become 100 kilonewton times 3 meters equals R sub 2 times 10 meters. Finally, the value of R sub 2 is equal to 30 kilonewton. Let us have now the summation of all vertical forces, or y equal to 0. Again, as we can see, R sub 1 and R sub 2 are having a direction of both upward. That's why we will be using positive sign convention on both. While the 100 kilonewton as resultant force is downward in its movement or direction. That's why we'll be using negative sign convention until we can get into this equation as R sub 1 plus R sub 2 minus 100 kilonewton equals 0. Then we can then calculate now for the value of R sub 1 since we already have a value for R sub 2 and that is 30 kilonewton. Finally, we have R sub 1 plus 30 kilonewton minus 100 kilonewton equals 0. What is then the value of R sub 1? R sub 1 is actually 70 kilonewton. Now we are ready to solve for the maximum shear load in this given situation. Actually, what is the highest reaction here? That is going to be our maximum shear load. And it only shows that in our calculations, the maximum shear load is actually 80 kilonewton because it is the greatest among all reactions calculated. Again, our answer, maximum shear load is 80 kilonewton. Thank you very much and God bless us all.